Okay, now we are on page 10. We've already done a little bit from page 10. I just wrote it on a separate sheet of paper, which I'm going to do this time as well. But we are going to be looking at ones like 6, 7, and 8, and 13 and 14 on page 10, so that you can know what to do with multiplying. I'll put my sheet of paper behind me here. So we're going to start here with number 6. Square root of 3 times square root of 6. Now, if you remember in our video yesterday or in our Google Meet on Friday, we talked about how if two things are multiplied together under a square root, then we could separate them into two. And then we talked about how you could go backwards. If there are two of them multiplied separated, you could put them together. So I could bring this together and do 3 times 6, which is 18. Now, normally I would not write this step here. I'm just showing you where it comes from. I go straight from there to square root of 18. Well, then we have to do everything we did yesterday. Does the square root of 18 have any perfect squares that go into it? So if you like the singles mingle method, you do 2 times 9 and 3 times 3. And when we write that under one square root, that's 2 times 3 times 3. So we have a pair of 3's that meet at the singles mingle. 3 times 3 is 9. The square root of 9 is 3. That goes out front and leaves me with the square root of 2 under there. So we have to get it together first, and then we have to break it down with any perfect squares that we might have. Now let's look at number 13, because number 13 is a little bit different here. Number 13 is 4 square roots of 10 times 3 square roots of 6. Now, we can use that rule for when they're under the square roots, but we can't put things that are not under the square roots together. So a long time ago, probably in elementary school, but I know it was mentioned in 6th grade for you, you learned something called the commutative property of multiplication. What the commutative property says, if two things are multiplied, the order does not matter. For instance, 2 times 3 is the same thing as 3 times 2. You can switch the order around. So we can switch the order in this around. Now I'm going to tell you, this step I'm getting ready to write, on a typical problem, I would not write. I'm showing you where it comes from. I will tell you what I would normally skip to. But commutative property says I can rearrange this order. So I could put the 4 and the 3 together, and the square root of 10 and the square root of 6 together. I could rearrange the order. And when I do that, I can now say 4 times 3 is 12, and 6 times 10 is 60. Now, I would normally be able to look at this one and say, okay, I'm going to multiply the coefficients. 4 times 3 is 12. And then I could look at this one, the square root of 10 and the square root of 6 is the square root of 60. Then I've got to try to break that down. So the 60 is what I'm worried about looking to see, is there a perfect square that will go into it? So 6 and 10, 2 and 3, 2 and 5. So I rewrite this as 2 times 2 times 3 times 5. Now we're looking for perfect squares. When you have a pair of numbers being multiplied together, that is a perfect square. That's the definition of a perfect square. So this 2 times 2 is going to go out front with the 12 that was already out front. And the 3 and 5 that were left at the singles mingle, they have to stay there 3 times 5. So 2 times 12 is 24, and 3 times 5 is 15. So now we need to practice some where you are multiplying them. I'm going to do one more together with you, number 14. I'm going to copy the problem, and then I'll slide my paper over. So again, I'm going to multiply the coefficients together. Well, this has a coefficient of 3. This has a coefficient of 1. We can't see it, but 1 times 3 is 3. And then I'm going to multiply together what is under the square root. So 3 times 3 is 9. X squared times x to the 4th is x to the 6th. This is one of the reasons we had to learn our monomial or exponent rules before doing this, because when we multiply things with the same base, we add the exponents. 2 plus 4 is 6. Now I try to break this down. Well, I noticed 9 is a perfect square. So the square root of 9 is 3. So this 3 was already out front. The square root of 9 is 3. And then this x to the 6th. Remember, I told you if it is an even number, we can just divide by 2 and put that out front. If it's an odd number, we would have to leave one of them under the square root. So 3 times 3 is 9. So 9 times x to the third. So the big thing I want you to get out of this lesson is if they're under the square root, we can multiply them together under the square root. If they're in front of the square roots, we can multiply them together in front and then break them down. So now you're going to do a con on practicing how to do this multiplying when you have the square roots and breaking them down.